Hello everyone, welcome to Applied Chemistry Tutorials. So today we are going to discuss about polynomials and factorization by splitting the middle term. So let's begin with a brief introduction. We are familiar with many algebraic expressions such as t square x minus 2tx plus 5, ax plus by plus cz, 2x minus 3y, 4y plus 3x to the power 0.5, etc. So now any algebraic expression consists of two parts. The first one is the constant terms, and for them the values don't change. The second part is the variable terms, and for them the values keep changing for a particular problem. So let's talk about this particular algebraic expression ax plus by plus cz. So let us consider that in this expression a, b and c are constants. Say a equals to 2, b equals to 3 and c equals to minus 5 for ease of understanding. And here x, y, z are variables. Then the expression becomes 2x plus 3y minus 5z. Similarly, for the same expression, if x, y, z are constants, and say x equals to minus 2, y equals to 4 and z equals to 7 for ease of understanding, and in this case a, b and c are variables, then the expression becomes minus 2a plus 4b plus 7c. Now let's talk about polynomial. So what is a polynomial? Polynomial is a type of algebraic expression. To be a polynomial, exponent of all the terms of an algebraic expression should be either positive whole numbers or 0, such as 0, 1, 2, 3, etc. So let us take an example. Here we are seeing an algebraic expression 3x squared minus 5x plus 7. So this can be rewritten as 3x squared minus 5x to the power 1 plus 7x to the power 0, because we know x to the power 1 is x and also x to the power 0 is equals to 1. So here we can see all the exponent for all the terms are either positive whole numbers or 0. So that means this particular algebraic expression is a polynomial. A second example, 2y minus root over of x. This can be rewritten as 2y to the power 1 minus x to the power half. Here definitely half is a fraction, so definitely this is not a polynomial. The third example, x minus 1 over x squared. So this can be rewritten as x to the power 1 minus x to the power minus 2. Again here this minus 2 exponent is not a positive number, so we can say that this is not a polynomial either. Another example, ax square plus c, and this particular algebraic expression can be rewritten as ax square plus cx to the power 0, because as we mentioned x to the power 0 is equals to 1, and therefore this particular algebraic expression is a polynomial because we can see only positive whole number and a 0 here. Now let us discuss about the terms and coefficients of polynomials. So let's discuss the terms and coefficients for polynomials with one variable, say x, for ease of understanding. And that algebraic expression of the polynomial is 3x squared minus 2x plus 9. So this can be rewritten as 3x squared minus 2x to the power 1 plus 9x to the power 0, as x to the power 0 is equals to 1. So here we can clearly see that this polynomial has three terms, 3x squared minus 2x and 9. For each term we have coefficients. For 3x squared, the coefficient of x square is 3. For minus 2x, the coefficient of x to the power 1 is minus 2. And for x to the power 0, which is equals to 1 and hidden with this term, so the coefficient is 9 here. Now as we are saying that x to the power 0 equals to 1, here is the proof for that. So x to the power 0 can be rewritten as x to the power m minus m, where m is any quantity. So that can be so that is equals to x to the power m over x to the power m, which is equals to 1. So that's how we can say that x to the power 0 equals to 1. Now, so any constant term such as 6 or a can be represented as a constant polynomial, such as 6 is equals to 6 multiplied by x to the power 0, and a is equals to a multiplied by x to the power 0. And similarly, 0 can be regarded as 0 polynomial. Now let us talk about the degree of polynomials. The highest power of the variable in a polynomial is known as the degree of polynomial. So in this polynomial, we can clearly see the highest power is 175. So definitely we can say that the degree of polynomial is 175. Another example, so in this polynomial we can see the highest power is 5. So the degree of this polynomial is 5. Another example, we can see the highest power is 12. Therefore the degree of polynomial is 12. Now, types of polynomials. So polynomials can be classified in many ways. Let's talk about the polynomials classified as the number of terms present in it. So monomials, the polynomials with one term, such as u to the power 5, x to the power minus 3, etc. Binomials, polynomials with two terms, and therefore the examples are t cube plus 1, y to the power 4 minus 1, etc. Trinomials, polynomials with three terms, such as x cube plus 3x square plus root over of 7, u square minus 2u plus pi, etc. And this can go so on and on. Another way to classify the polynomials is with their degree. So linear polynomial, the polynomials with degree 1. So the example is ay plus root over of 2, 2x plus 3, etc. Quadratic polynomials, the polynomials with degree 2. And examples are 5x square plus 3x minus 2 pi, y square plus y plus 1, etc. The cubic polynomials, the polynomials with degree 3, and the examples are 6 minus x square minus 5x cube, t cube minus 3t plus 4, etc. And this can go so on and on. Now let's talk about the factorization of quadratic polynomials. So factorization by splitting the middle term, or commonly known as middle term splitting or middle term factor. Say we need to factorize a given quadratic trinomial px equals to ax square plus bx plus c. Then we can rewrite it as ax square plus bx plus c is equals to ax square plus b1 plus b2 multiplied by x plus c, where we can definitely see that b is split into b1 plus b2, and it should be in such a way that a multiplied by c should be equals to b1 multiplied by b2. Also, this can only happen for the trinomials, and it should be in written in the format a constant multiplied by a variable square, and the constant multiplied by the same variable to the power 1 plus another constant multiplied by the variable to the power 0. Now this particular trinomial can be rewritten as ax square plus b1x plus b2x plus c, and we can take a common factor x out of the first two terms, so we can have x multiplied by ax plus b1. b2x can be rewritten as ac over b1 multiplied by x, because b2 is equals to ac over b1, that we can see from the criterion itself, that ac equals to b1 b2. So now we are keeping the first two terms as it is, that is x multiplied by ax plus b1, and here from the third and fourth term we can say that we can take a common factor out of it, so c over b1 multiplied by ax plus b1. So for ease of understanding, you can see that c over b1 multiplied by b1 is equals to c, or this term indicated here. So finally we can take the ax plus b1 term as a common factor from both of these terms, and then we can have x plus c over b1. One thing to note, that this c over b1 can be a whole number depending on the problem. So this is the general way to factorize by splitting the middle term. So let us take a few examples of factorization by splitting the middle term. Factorize x square plus 5x plus 6. So this can be rewritten as x square plus 3 plus 2 multiplied by x plus 6, so that 3 plus 2 is equals to 5, and 3 multiplied by 2 equals to 6, which is equals to 6 multiplied by 1. So it matches the criterion. So it can be rewritten as x square plus 3x plus 2x plus 6. So now from the first two terms we can take x as the common factor, so we are having x plus 3 from here, and from the third and fourth term if we take 2 as the common factor, we will have x plus 3 as well. So the factorized form is x plus 3 if we take as the common factor from both of these terms multiplied by x plus 2. Now another problem, factorize 2y square minus 7y plus 3. So the problem statement is 2y square minus 7y plus 3, and it needs to be factorized by splitting the middle term. So we are splitting the middle term here. So first thing, we need to rewrite this problem as ax square plus bx plus c format. So 2y square plus minus 7 multiplied by y plus 3. So we are splitting the term minus 7 as minus 6 plus minus 1. So let's check it. Minus 6 plus minus 1 is minus 7, and minus 6 multiplied by minus 1 is 6, which is equals to 3 multiplied by 2. So it matches the criterion. So we can expand it. 2y square minus 6y minus y plus 3. Now from the first two terms we can take 2y as the common factor. So 2y multiplied by y minus 3. And from the third and fourth term we can take minus 1 as the common factor, so we are having y minus 3 as well. So from both of these terms we can have y minus 3 as the common factor, which left us 2y minus 1. So the factorized form is y minus 3 multiplied by 2y minus 1. So these are a couple of examples for the factorization by splitting the middle term, and there are many other ways to factorize the quadratic polynomials and also other types of polynomials, and we will discuss those in our next videos. And to know more about polynomials, uh, please stay tuned with our channel and like, comment and subscribe. Thank you.